Hey everybody, this is Matt Morgan. In this lesson we're going to talk about measurement and significant figures from Wiley section 1-1. In this lesson we'll talk about chemistry and its relationship to measurement, precision and accuracy, determining uncertainty, those homework problems, and finally significant figures. Zero is a significant figure, how to deal with significant figures in addition and subtraction, and multiplication and division. So this is a busy lesson. Let's get going. So science and chemistry specifically are all about taking measurements. We measure mass, temperature, volume, pH. The better our measurements, the better our science is. Unfortunately, measurements are subject to errors and uncertainty. The people operating the measuring devices are only human, and we make mistakes. So precision and accuracy in everyday conversation are often used interchangeably, but in science, these words have specific meanings. Precision is the ability to measure the same value over and over to get the same result. Accuracy is the ability to measure close to an accepted value to get the right measurement. This grouping is precise. They're all very close together, but not very accurate, not close to the center of the target. This grouping is neither precise nor accurate. The shots are all over the place, and none of them are near the center of our target. Our final grouping is both precise and accurate, very close together, very near the center of our target. That's how we view measurements. So we express the numbers of our measurements in terms of significant figures. Wiley defines significant figures as a digit that is either reliably known or closely estimated. Common sense tells us that we shouldn't use any more digits than our measuring devices can give us. Unfortunately, devices like digital computers and electronic calculators can displace our common sense. It will display many more digits than reflect our measurement. Those extra digits are not significant. We don't want to display those. We don't want to write those in our answer. So significant figures have come about. Whether you love or hate them, they are an important part of the chemistry and science experience. Most numbers that you use in a chemistry problem are the result of some kind of measurements, and therefore are subject to the rules of significant figures. Determining significant figures is easy if we have a digital device like a balance or a digital thermometer. So when using these devices, just record the number in the display. The last digit is assumed to be uncertain. In this scale, we have 3 decimal places. That last digit, that 0.003, is assumed to be uncertain. Analog devices are a little more tricky. What we want to do: record using the graduations on the device, and then estimate one more digit. We know that this estimation is uncertain. Let's take this example of a steel rod being measured by a ruler in centimeters. The ruler has marks to 0.1 centimeters, but we can see that our measurement is just past the 9.1. So what we do is we'll say 9.11, 9.12. We're estimating that last digit. So the 0.01 centimeters is considered uncertain. the final digit uncertain. We are plus or minus 1 of the smallest digit displayed. In that last steel rod example, we'll say it was 9.12. The uncertainty is plus or minus 0.01. We're not sure if it was 9.11, 9.12. That digit is uncertain. Let's look at some homework problems. They ask us to determine the uncertainty of specific measurements. If our number is 4002, that number has 4 significant figures. The smallest digit is 1. So the uncertainty in this measurement is plus or minus 1 meter. Let's do one more example. What is the uncertainty of the measurement? 0.060. The smallest decimal place is 0.000, so our uncertainty is plus or minus 0.001. We take our smallest digit as our uncertainty. Zeros are tricky. Let's talk about them a little bit more. Significant digits reflect how well we can measure. Digits that tell us the size of a number, not considered significant. So in these two examples, 3200, the last two zeros, not significant. In 0.004709, those first two digits after the decimal are not significant. And that zero before the decimal, not significant either. It merely points out, emphasizes that there is a decimal point there. That 0 between the 7 and the 9, however, is significant. In this example, our 3200 has 2 significant figures. Our 0.004709 has 4 significant figures. Practice will make this better. Let's now talk about rules for addition and subtraction of significant figures. You want to report your answer using the fewest decimal places of numbers that you add or subtract. Let's look at an example. Take your calculator, add these numbers together, get an answer, and we will talk about the significant figures. I'll wait for a few seconds, and of course you can always pause while you add these numbers. The answer will have one number to the right of the decimal. Because of these given numbers, the 0.1 has the fewest decimal places. So the answer I get, 14.9, be sure to round that number appropriately. Let's do a subtraction. Okay, in this case, our answer will have 2 decimal places because 0.25 has the smallest number of decimals. I do that subtraction in my calculator, round to 2 decimal places, I get 3.62. Now let's talk about multiplication and division. When multiplying and dividing numbers, the answer uses the smallest number of significant figures of the given values. Do this math problem on your calculator. 5.67 times 0.43 divided by 2.785. The answer will have 2 significant figures from one of our given values, 0.43. I get 0.88. Multiplication and division are actually easier than addition and subtraction. Also note that addition and subtraction can change the number of significant figures of your answer. So big picture, you probably won't use 1 sig fig unless that's what you're given in the problem. You will not want to write down your answer using all the digits in your calculator. You probably won't be given 8 or 9 or 10 significant figures. We just can't measure that well. Now, unless the question specifically asks about sig fig, the Wiley homework problems usually disable the sig fig checker anyway. And final point about significant figures. The assessments in this course, the pre-assessments and the objective assessments, are multiple choice. So, significant figures are important. They come from measurements. But remember what this course is about. So we talked about precision, accuracy, measurements. We talked about significant figures. Always, if you have a question, contact a course mentor. Here is our contact information. The main job of your course mentors is to enable your success in these courses. You can email us at the group inbox at chemistry@wgu.edu, or you will find contact information for your individual course mentor in your course of study.